Okay, we are going to complete the square to rewrite a quadratic in vertex form. So this is a quadratic function, y equals something involving x squared, but you can use this technique to rewrite any kind of quadratic like square expression like this. So the first thing I'm going to do is to deal with this leading coefficient. Notice that everything here is a multiple of 3, so we can factor 3 out. Even if it wasn't a nice like round multiple, we could still factor the 3 out of everything. So I'm going to factor out 3, which leaves x squared minus 6x plus 4. Okay, and then completing the square really kind of hinges on this middle term. So completing the square, we're trying to find a perfect square factorization of this quadratic. So if we're going to factor this as a perfect square, that means that when we expand the middle term, the outer and inner parts of the product from doing a binomial expansion, those parts of the product are going to be identical because the factors are identical. So I'm going to divide that b term in half. So in this case, that'd be minus 3x and minus 3x. And then looking at that tells me what the factors would need to look like for this perfect square. So I'm going to leave a little bit of space here. In order to, let's see, big set of parentheses here for that, that factor of 3. And then these are going to be my factors. So x squared minus 3x minus 3x would come from factors that look like that. And if you think about expanding that, x squared minus 3x, check, check, minus 3x, and then the part that we're missing, and that's where the completing in completing the square comes from, is that the last part of that product would be plus 9. The problem is that we don't have plus 9, we have 4. So essentially what we do is borrow that 9. You can write that like I've done here as adding 9 and then subtracting 9 again, so that those would drop out if we let them, but we're using this one to factor this stuff. Or think about it again as borrowing 9 from 4, which leaves behind negative 5. Okay, and then the final thing I'm going to do to clean things up is just take this 3 and distribute it back into these two big pieces in here. So 3, I have x minus 3 times itself. So I'm going to write that as x minus 3 squared minus 3 times 5, 15. So this is an equivalent way to write this same quadratic expression. Again, this is in this vertex form where I can look at this and sort of read off the transformations that this is 3 to the right with a vertical stretch and then shifted down 15. And that's this middle part is what completing the square looks like. Okay, cool. Hope that helps. Please let me know if you have questions.